The elevator was like connecting things one more time.
Okay, today we're going to do derivatives. Tomorrow we're going to do integrals. I think, I'm not 100% sure, but I think I separated the homework appropriately. So if you do have an integral problem on the homework tonight, don't freak out. Okay, we'll do it tomorrow. But I only want to talk about derivatives today. We want to look at something like a to the x. Okay. Identical to e to the x, because e is a constant, a is a constant. It's just not going to be e. So nice things like natural log of e to the x won't be as simple. It requires a little bit of sneakiness. Okay, so we're going to start by defining a to the x as being e to the natural log of a to the x. Now, where did I mean, it appears I just pulled that out of my butt, which I did. But I know where we're going, so I'm setting us up to get there. Right. Do you understand why that's true? What's e to the natural log of anything? Anything. So I took a to the x, and then rewrote the right side as e to the natural log of x. Which means this is also equal to e raised to the x times the natural log of a. That's good, right? We're solidary natural log properties. Bring the exponent out in front. And this left side stays a to the x. So my goal here is I want to know what is the derivative of a to the x. So simple rule says if I do something to one side, I have to do it to the other side. We'll leave the left-hand side alone because that's what we're trying to work towards. We should be able to take the derivative of the right-hand side, though. What's the derivative of e to the anything? E to the anything. Whoops. I keep writing that as an h, not a... That's a natural log, not an LH. Times? Yep.
1 over a.
Why?
Because it's the natural log of a.
Keep going.
The derivative of the natural log of a.
Let's back up. What's the derivative of this? E to the x natural log a. What's the derivative of e to the anything? With the chain rule. Okay, so there's the e to the anything. Now I need the chain rule. What's the derivative of x times the natural log of a? You could do product rule. So if we have x times the natural log of a, you could do product rule. However, what can you tell me about that? You're overthinking it.
It's just
Mm-mm. That's a constant.
It goes away.
Oh.
Zero.
So really, if I rewrote it this way, what's the derivative of this?
Zero.
No. Hold on. What's the derivative of this? 2. What's the derivative of this? Natural log of a. Let's stop for a second, make sure everybody's with me. Yes? Okay, anytime you have a constant in front of a variable, the derivative of that is just the constant. So again, recognizing that the natural log of a is a constant, if we write it this way, you take the natural or derivative of that and we get the natural log a. Okay, let me get this mess out of the way so we don't get confused. And clean things up a little bit. What is this?
A to the x.
How do you know that?
The first steps.
That's how we defined it, right?
leave it like
Yeah. So if we want to take the derivative of some constant other than e to the x, we will get itself times the natural log of a. Question?
Do you raise the log to the power of a to the x?
You could.
Oh,
I mean, you know, you could hit yourself in the head with a
Yeah.
hammer, but that doesn't mean you want to.
yeah.
So, does that answer your question?
Yeah.
Okay, good. Any problems with that? Okay. What if it's not an x? What if it's a u? Same thing? Same. So the derivative with respect to x of a to the u is equal to a to the u times the natural log of a.
You.
Me?
Yes.
Oh, that looks good.
No, not me.
Shouldn't it be du?
du
dx.
dx.
For the first one, too, right? No. Well, I mean,
You have to chain. The only difference between the blue and the red is you have to chain on the derivative of u. Okay, so if it's a function other than x, let's say x squared plus 2, when you take the derivative there, you've got itself times the natural log of the base times the derivative of that exponent. Same thing happens in the blue, except the derivative of x is just 1. So we get back to that whole chain thing. How do you want to think about it? Do you want to worry about it as a chain if it's something other than x, or do you want to chain it on all the time and just realize that the derivative of x is 1? It's entirely up to you. And that's important, so I'll put it in a pretty green, squiggly shape. How are we doing so far? Little refresher. Let's suppose I have log base a of x. Do you remember change of base form? A on top or x on top? It's x actually. 50-50 chance, yeah. And that's easy to remember because the x is higher than the a, then that reminds you that the x is on top. Right,
Yeah, what we just did, if you have like 3x plus 5 is like a to 3x plus 5, would it be the same thing?
yes, but you have to chain on the derivative of 3x. I got a couple examples coming up.
Oh,
And let me give you all the necessary stuff that you need. We did that, we did that, we did that, we did that, we did that. Oh, one last thing, and then we'll do some examples. Then we'll look at homework. What happens if we want to take the derivative of something like this? So what if it's not the derivative of a natural log? Because if it's the derivative of a natural log, that's easy. That's u prime over u. This one now it's not e, it's some number other than e. 6, 5, 9, whatever, a billion. We get this nice little formula. I don't really want to derive this one like I did the last one because it's a little nasty. But it's doable, it's just a little nasty. It involves taking a change of base form and then doing a quotient rule. And when everything is said and done, we end up with this puppy. These are both flashcard worthy because it's easy to screw up where that natural log is. When you're taking the natural log with the base a, that ends up in the bottom along with u. If you're doing the natural log of an exponent, base a raised to some exponent, then it all ends up in the same spot. Yes, sir?
So where does the u on the bottom come from? Is it from a u prime over u?
Yep.
Like, okay.
Yeah. Again, you would take this and rewrite it as a change of base form, then do a quotient rule, and when everything settles down, you're left with a u on the bottom.
Okay.
Couple quick examples for you, if I can find my notes. Let's leave this up here. F of x, call this number 1. F of x is equal to 12 raised to the 6 plus 3x squared. 3x squared. What's F prime? There's 2 examples. Almost. Remember, that's U now, not just X. Yep. Oh, then that's good. Okay, let's take a look at number 1. Most people made the same, if you made a mistake, most people made the same mistake, so let's see where you're at. Okay, I'm at a pen not working anymore. Itself times the natural log of 12 times, what did most of you forget? The 6x, which is a derivative of the exponent up on top. And there's not a lot to clean up with that. You know, you just leave it as is. All right, how about this guy? What's y prime? Okay. No. That's a change of base. We want the derivative. What's a? 3. What's u? X. Okay, plug and chug. 1 over natural log of 3 times x times du dx, which is just 1. And personally, that's a little sloppy. I would prefer that you write it this way so we don't get confused with whether or not that x is being taken as a natural log. Not done yet, because I know I want to do it at the point 27 comma 3. So I got to put 27 in there. What's 27? Yes, sir.
Do you agree how you have the y prime of 1 over?
Yeah. So I have a log base 3 of x. That relies on this.
Yeah.
A is 3, u is x.
Oh.
So 1 over the natural log of 3, because that's my a, times x, which is my u.
Is that always just the pattern then?
Yep.
Oh.
times the derivative of that thing, and since it's just x, it's going to be 1. What's that equal to?
Some constant.
I'm sorry?
0.034.
Did you do that on your calculator?
Yeah.
Oh, good, I was a little worried there. Thought maybe you were like Rain Man and did that in pen. Can you get it without the calculator? No, John? You can't?
Not likely.
Close.
You don't know what power you raise e to get 3 to the 27th?
It's 30.
I don't either. Just leave it like that. So that whole thing is point, would say point?
0.034.
Okay. And since this doesn't simplify nicely, remember we want to do the equation of tangent line, so we would get y minus 3 equals 1 over this mess. There's our final answer.
So if you plug in 3 for y prime, it would just screw it up.
Yeah. Yeah. Because that's not y prime, that's y. So these are just examples. Unfortunately, like I've said in the past, I'm not a big fan of memorizing, but pretty much these two formulas are memorization stuff. You could go through the derivation like I showed you on the first one over and over again, but it's not really worth your time. Whereas if you just flashcard that up and realize how you need to handle that, life will be so much easier. Okay, we good? Questions, concerns? Outstanding. Tomorrow we'll do the